All right, today we're going to look at some integrals. We know that there are many different techniques we have to be able to solve integrals and be able to evaluate them. And so we've been looking at integration by parts. So hopefully when you're in this problem, evaluate this integral from 1 to 2 of x cubed times ln of x dx, and it says right up here, section 7.1, you should think integration by parts. So the first question is, what are the parts that we're going to break this integral up into? Well, we got this natural log of x and this x cubed. Logically, we should probably use one or the other. I would pick natural log of x to be our u value that we're going to find the derivative of, because that gets rid of the natural log completely. So that's what we're precisely going to do. We're going to let u equal natural log of x and dv be x cubed dx. So now we need to find du and we need to find v. Du, just take the derivative, so du is 1 over x dx, and then v is just x to the 4th over 4. Pretty simple, right? Now we just use our formula, which that means this integral is equal to uv minus the integral of v du. Okay? So by integration of parts, and don't forget, you need to evaluate at the bounds. So this integral here, right? We have our parts, and then we took v times u, evaluated it at the bounds, and then we are subtracting this new integral, which will hopefully be easier to solve. So let's evaluate what we used by integration by parts. So this part here is just 4 ln of 2. If you want to look back, you can just plug in the 2 here. You get 2 to the 4th over 4, which should just be 4, and natural log of 2. Natural log of 1 is, remember, 0. Therefore, that whole part, the subtraction part in the evaluation, just goes away. So we got that 4 natural log of 2, and when we simplified the other integral, it's just now a polynomial, which we've been doing for a long, long time. So this part is just equal to 4 natural log of 2 minus x to the 4th over 16, evaluated from 1 to 2. And then it's just plug and chug. You get minus 1 plus 1/16, you get minus 15/16. And that is the whole answer to this integral, which was made a lot simpler just by using integration by parts. So just remember, if you got that natural log times a polynomial, probably the best thing to do is attack it by using integration by parts with that u value being that natural log of x.